Hey guys, today we're going to be looking at our first new lesson of this new unit, which is all about exponents. So today we'll be looking at how to multiply monomials. For those of you who have not seen the prefix mono before, it means one. So we're going to be looking at one term, or something that looks like negative 3x squared. So remember, terms are separated by addition and subtraction. So if we're looking at monomials, there won't be a plus or a minus. For 1 and 2, we're given these expressions in expanded form, and we can rewrite it using the base and the exponent to represent how many times the number was being multiplied by itself. So 1 would become 4 to the 7th. Number 2 would become k to the power of 5. Just like we can rewrite expanded form into exponential form, we can go from exponential form back into standard form. So 3 to the 4th is really 3 times 3 times 3 times 3. Remember, that does not mean 3 times 4. It means 3 multiplied by itself 4 times. So x to the 5th would become x times x times x times x times x. And I want to take this moment to kind of review a little bit about exponents. So if we have two different expressions that look like this, exponents are really lazy, and they're only going to go to what's closest to them. So for this first example, that's really only going to go to the 5. So this is negative 5 and then times 5, which actually becomes a negative 25. Whereas for the second example, the negative is included in the parentheses, which means the exponent also needs to go to it. So this is saying negative 5 times negative 5, which does become a positive 25. So sorry about my dog. As we continue on looking at these examples, please keep in mind that an exponent will only go to what's closest to it unless there is parentheses. So we're going to take a look at some vocabulary. Our base is the number or variable being raised to a power. And the exponent tells us how many times the base is being multiplied by itself. Our coefficient is a number in front of a variable. And a constant is just a number by itself. When we combine like terms, they have to have the same variable and exponent. For example, something like 4x cubed and negative 2x cubed. They have the same variable and the same exponent. Something like 2x to the 4th and then 5x cubed. Even though they have the same variable, they don't have the same exponent, so these are not going to be like terms. When we go to label this next part where it's 5x to the 6th, the 6th is our exponent. And because that 5 is not included in the parentheses, x is my only base. The 5, which is the number in front of the variable, would be what's called our coefficient. When we come down here to review combining like terms, remember that they have to have the same exponents and variables. So I'm going to start with negative 4x cubed, and it has a like term of 10x cubed. So that combines to make 6x to the power of 3. Then we look at positive 5x and a negative 4x. That combines to just make a positive x. Our positive 6 here doesn't have a like term, but it doesn't go away, so we bring it down there. Now to the new stuff. A product is an answer to a multiplication problem. And a power is just another word for an exponent. So when I'm looking and I have 2 to the third, what that really means is 2 multiplied by itself 3 times, which I can write in expanded form. And then the same for x to the fourth. We would have x times x times x. So then now we see 4 to the third times 4 to the fifth. Well, what that really says is 4 times 4 times 4, and then times 4 times 4 times 4 times 4 times 4. These are all the same base, so I can rewrite that as 4 to the power of 8. And I can apply that same thinking to y to the fourth, which is y times y times y, then times y squared, which is y times itself. And again, since these are all that same base, I can just rewrite it as y to the sixth. So when you take a look at the answers and the problems, notice that the simplified version came from adding the 2 exponents together. This is where we get our first product of powers rule. What this means is that when you multiply the same base, you add the exponents. And we can actually rewrite this into an algebraic rule, and this is how you'll see it on your formula chart for star. We get a to the power of m, so any base a with an exponent of m, when multiplied with the same base of a and an exponent of n, the simplified form, you get a to the power of m plus n. All this means is that when you're multiplying those same bases, you add the exponents. All right, let's practice. Our first example, we have a to the fourth times b to the fifth times a squared. Because I know that it does not matter what order I multiply in, I'm going to rearrange this big multiplication problem. I'm going to say a squared times a to the fourth, and then all of that times b to the fifth. So notice I'm just rearranging it with the same like bases. And when I multiply same bases, that's when I can add those exponents. So I get a to the sixth and then b to the fifth. And I can't simplify it any further, so this is my simplified answer. When we look at number 2, now we have some coefficients that are not 1. I have a coefficient of 6, a coefficient of 2, and then right there, that's a coefficient of 1 in front of the w to the sixth. So now I'm going to take out the coefficients and multiply them out front. And then I'm going to group my w's together. And then v squared doesn't have any other friend with it. I know I can simplify 6 times 2, that gives me 12. And then w to the fifth times w to the sixth, because they have the same base, I can add the exponents to get w to the 11th. And then v squared because there was no other v's. This is my simplified answer, so I'm done. So the same thinking for number 3. I have a coefficient of 3. The coefficient right there is 1, and the coefficient here is 5. So I will take and group all of my coefficients out front. Then I'm going to group my same bases. So we have m to the 7th, m squared, and then m cubed, and now n to the 5th, and n to the 8th. All I'm doing is just rewriting the multiplication problem in a different way because it does not matter what order I multiply in. So this simplifies to 15, and here I'm multiplying same bases so I can add my exponents. So this will simplify to m to the 12th, And then our second grouping of n will simplify to n to the power of 13. On number 4, notice now here for our coefficients, I don't see a number, but just a negative. Guys, this is an implied -1. So when I pull out the coefficients, that's a -1 times a -1 times a -1. And in our first group of t right here, I don't see an exponent on the t, which means it's an implied 1 because it has to be there. So we would have t to the first, t cubed, and then t to the 6th. When you see those variables without an exponent, I highly recommend that you put in that understood one, so then when it comes to simplifying it here and adding them together, you don't forget the 1. So I know -1 times -1 times -1 simplifies to a -1. And then t to the first times t cubed times t to the 6th, because those are the same bases, I can add my exponents. So I get t to the power of 10. And I don't really need to write that -1, so I can actually write that as -t to the 10th. However, both of these are the same and are both acceptable. So at this moment, I want you to pause the video. I want you to attempt number 5 and number 6. And when you're ready, unpause to check your work. All right, I hope we did really good, you guys. So now we're going to move on to our second rule. We have a power of a power. Well, what that really means is that we have an exponent raised to another exponent. So we have x squared, and all of that, remember it's inside of the parentheses, is being raised to the power of 4. So that means I'm saying x squared times itself 4 times. But based on our previous rule that says when I multiply the same bases, which is what's essentially doing here, I can actually add my exponents. So this simplifies to x to the 8th. We can take the same idea to kind of investigate y to the 5th, all raised to the power of 3. So y to the 5th times y to the 5th times y to the 5th. Again, and I'm multiplying the same base. So that means I can add my exponents. So I get y to the 15th. I want you to take a moment and look at the solution, the simplified version, as well as the original problem. What do you notice, or what relationship do you see? I really hope you guys saw it, but if you didn't, notice that the two exponents were multiplied together to get the simplified one. And that's where we get our power of a power rule. When an exponent, or when a power, is raised to a power, you multiply the exponents. Now the difference here than what we just looked at is this time I have an exponent actually raised to another exponent. So our algebraic rule is any base a raised to the power of m. If you take that and then raise it to a power of n, the simplified version is actually the same base of a to the power of m times n. And I want you to almost kind of think of it like it distributes in. So that exponent distributes in and multiplies with all of the exponents inside of the parentheses. And when we solve these problems, we have to deal with the outermost exponents first. Outermost exponents first. That's going to be important to remember. So let's take a look at number 1. For number 1, we have 5x squared times x squared all to the power of 2. So right here, I see that I have a power raised to another power, which means that that 2 is going to multiply with my exponents. So my 5x squared will stay the same for now, and x squared raised to the power of 2 becomes x to the 4th. And now that I'm here, I'm still not fully simplified because I'm multiplying same bases right now, which means I can add those exponents to get 5x to the 6th. So then we look at number 2, and now I have 2 different bases that are raised to a power. So the outer 2 will multiply in, and the outer 4 will multiply in. This 3 stays out front, and when I have powers raised to a power, that's when I multiply those 2 exponents. So this becomes x to the 4th, the next one becomes x to the 12th, and then times 4x. And remember, when a variable doesn't have an exponent, it's an understood one. So now, just like the ones that we did previously, I'm going to take the coefficients and I'm going to pull them out front. And then I'm going to group my like bases. 3 times 4 gives me 12. And then since I'm multiplying same bases here, that's when I add my exponents to get x to the power of 17. So I want you to try number 3 on your own. So pause the video, and then whenever you're done, unpause to check your work. How did we do? I could see where some people might get tripped up is going to be right in this part right here. This b on the inside of the parentheses has an exponent of 1. So when the 5 multiplies in, it becomes b to the 5th, which will combine with your b to the 3rd to give you the b to the 8th. All right, number 4. 1/2 to the power of 3. Guys, just because it's a fraction doesn't mean anything changes. This really just says 1/2 times 1/2 times 1/2 right there. And when you multiply fractions, you multiply numerators to numerators and denominators to denominators, which really gives you 1 cubed over 2 cubed. So when you see your numbers inside of the fraction, when you don't see your exponent, it's an understood 1. So that 3 multiplied into both of them to give us 1 cubed over 2 cubed, which we know we can simplify to 1 over 8. So we have 1 over 8, and then now I have my powers raised to a power here. And when powers are raised to a power, you multiply them. So now we have x to the 4th and then x to the 20th. And since we are multiplying same bases now, x to the 4th and x to the 20th becomes x to the 24th. You could write it like this, or you could also write it as x to the 24th over 8. These are equivalent expressions. They are the same. So at this time, I want you to take the video and pause it, and I want you to do number 5 and number 6 on your own. And when you're ready to check them, unpause. All right, that brings us to the end of the first 2 rules. So now we're going to look at power of a product rule. So we have 3pq all to the power of 5. And what that means is 3pq is multiplied by itself 5 times. Which I can rearrange. And really, I'm multiplying 3 by itself 5 times. So I'm just grouping like bases. P by itself 5 times. And then Q by itself. And when you multiply those same bases, that's when you can add your exponents. So you get 3 to the 5th, P to the 5th, and Q to the 5th. And if we think about what we just talked about with our second rule, if I don't see an exponent on a variable or a number, that means it's an understood one. Which means even when there's more than one thing in my parentheses, if it's a power raised to a power, it's still going to multiply in. So our rule means powers raised to a power. That means that you multiply the exponents. So our rule here, if I have AB and it's all to the power of m, that means that I have a to the power of m and b to the power of m, because it's going to go to both of the things in the parentheses. So just like the one that we did, our exponent here was 5 to the first, p to the first, and q to the first. So when powers are raised to a power, you multiply your exponents to get 5 to the 5th, p to the 5th, and q to the 5th. Now, for sake of time, I'm not going to evaluate this 5 to the 5th right here, but you would use your calculator to find what that is, and that would be your coefficient. You would want to simplify that number all the way, and then you would have p to the 5th and then q to the 5th. But for sake of time, we are not going to do that today. For number 2, our exponent on 2x and y is 1, 3x and y is 1, and 4x and y is 1. And again, exponents raised to other exponents, that's when you multiply them. So this becomes 2 squared, x squared, y squared, times 3 to the 4th, x to the 4th, y to the 4th, and then times 4, x to the 1st, and y to the 1st. So I'm going to regroup my coefficients out front. So 2 squared times 3 to the 4th times 4. Then I'm going to group my like bases. So I have x squared, x to the 4th, and x to the 1st. And then y squared, y to the 4th, and y to the 1st. Again, for sake of time, normally you would plug this into the calculator to see what actual number it was, but I'm not going to do that. So we'll leave it as 2 squared times 3 to the 4th times 4. Then we get here, and we have x squared times x to the 4th times x to the 1st. And when I multiply those same bases, that's when I'm adding my exponents. So I get x to the 7th, and then y to the 7th as well. And we're done. And again, guys, remember that this part right here is not fully simplified, but I'm just trying to save some time on your video for you. So I want you to take a moment and do number 3 on your own. When you're ready to check your work, please unpause the video. All right, moving on to example number 4. We have 1/2 xy cubed times 1/4 xy squared. So this 3, again, power raised to a power. The exponent on the 1 is 1, and the exponent on the 2 is 2. Same with x and y, and the same with the 1 in the numerator and the 4 in the denominator, as well as the other x and the y. So when we raise our powers to powers, we multiply them. So I get 1 cubed over 2 cubed, x cubed, y cubed, times 1 squared over 4 squared, x squared, and y squared. 1 cubed and 2 cubed makes 1/8. 1 squared over 4 squared becomes 1/16. So I'm going to go ahead and group those out front. And then I'm going to group my like bases. One-eighth times 1/16 becomes 1/28. 1 over 128. X cubed times x squared, we get x to the 5th. Y cubed times y squared, we get y to the 5th. And that is our answer. So I want you to take this moment and pause the video and look at number 5 and 6. And I want you to try these on your own. When you're ready to check your work, unpause the video. I do want to take a moment, you guys, now that you're checking, and again, just remind you that this would not be the complete simplified version of that answer. I am just trying to save some time and not have to use the calculator for all of that. Moving on along to our last rule. We have a monomial, again, which is just one term. Oops. And then we want to know, what does negative 6x squared y to the 4th all to the power of 3 means? Well, that really means this base right here multiplied by itself 3 times. So that would become negative 6 to the power of 3, because that exponent is a 1, x to the power of 6, and then y to the power of 4. So we're kind of taking everything we've talked about and all combining it. And really just the biggest thing that I need you guys to take away is that when you have a power raised to a power, you multiply the exponents. So our algebraic rule right here would be a to the power of m, b to the power of n. So now we have 2 different bases with 2 different exponents, and all of this, let's say, is raised to the power of p. Well, that p is going to multiply into all of those exponents, so we get a to the power of m times p and b to the power of n times p. So it's the same idea, just with more pieces now. So now we're going to look at example 1. And we have negative 5x squared y cubed z to the 5th all to the power of 3. So that exponent on the negative 5 is a 1 right there. So when that 3 multiplies in, this becomes negative 5 to the power of 3. X squared all to the power of 3 becomes x to the 6th. We get y to the 9th, and then z to the 15th. Now this guy right here, guys, we can simplify. Negative 5 times negative 5 is a positive 25. Multiplied by another negative 5 is negative 125. X to the 6th, y to the 9th, and then z to the 15th. This is our simplified answer. So for our next one, for number 2, that 2, that outer 2 right there, he's going to go to the 1 that's on the 2 right now, the x squared, and then the y. And that y has an exponent of 1. And then our 4 over here is going to go to the 3, the x cubed, and the y squared. So we get 2 squared times x to the 4th times y squared, multiplied by 3 to the 4th, x to the 12th, and y to the 8th, multiplied by 4 times x, y. Remember, when you don't see those exponents on the variables, it's an understood 1. So I'm going to regroup all my coefficients out front. So we get 2 squared times 3 to the 4th times 4. And then we'll group our like bases. So we have x to the 4th, x to the 12th, and then x to the 1st. Then we get y squared, y to the 8th, and y to the 1st. So I'm going to go ahead and leave those coefficients as is, just because I don't want to take the time to do that. But you guys with your calculators at school, please go ahead and find that. So I'm going to write 2 squared times 3 to the 4th times 4. And when I multiply these same bases right here, that's when I add my exponents. So I get x to the power of 17, and then y to the power of 11. And we are done. So I want you to take a moment and do number 3 on your own. When you're ready to check your work, please unpause the video and take a look to see how you did. All right, you guys, let's see. We have 3 more. And I want you guys to do these on your own as well. And I want you to think about the ones that we've done already and apply your new learning. So whenever you're done and you're ready to check your work, please unpause the video to see how you did. All right, guys, that is our last one. Please check, and I hope you guys did well. If you guys need any help, please don't hesitate to reach out to me, Mrs. Garcia, or come to Hawk Lab. See you guys for the next lesson.